this, turn on this. Oh my God, there are people here already. Turn on this. This.
Morning.
Good morning. How are you? You know what? I'm not doing too bad. I was kind of nervous about everything. I think I'm feeling okay now. Are you guys seeing the screen okay? Is it hard to see? I wonder if it's too much light coming in there. You want to try closing that? Hi, how are you? Well, it was good till we looked at that.
Do you have anything for Veronica?
No, I don't. Thank you.
Yep.
Not at this moment, anyway. Oh yeah, I do.
Okay. What?
Have you? You see that big pile of papers?
This one?
Yeah. Have I had you guys go through that and separate stuff?
Okay. This one's yours or just this one?
Both of those.
Okay.
Okay. Do 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 do. Do 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 do. Do 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 do. Do 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 do.
Good. How are you? Morning.
Good morning, Mr. Sunshine. You brighten up my day. Oh, you know what else I gotta do? I gotta do this. Darcy, have you always been that tall?
Yeah.
Oh, remind me of how you can get 2 types of extra credit. Right? Everybody likes extra credit because it's like apple pie. Do you guys like apple pie? I love pie. Pie is my favorite. I gave up. I don't have to eat cookies anymore. I don't have to eat cake, because I weighed a lot. Okay. And so I don't think I ate them because I liked them, because it was easy to give up. You know what I'm saying? I see a cookie, I don't have to eat it. Okay. Yeah. And I see a piece of cake, I don't have to eat it. But I really like pie. I have to eat a piece of pie. Zach Kozlowski, do you like pie?
I do like pie.
Oh, what kind of? I like every kind of pie.
Same.
What about you, Jacob? Do you like pies? I love pie. My favorite pie is my wife made it for me, makes it for me on my birthday. And it's rhubarb custard pie. It's really good. My youngest son likes raspberry pie. So maybe, we might see him on Saturday. So we might have Raspberry Pi. I just might mention it just to see how that goes. Cole, are you here?
Yes.
Haley?
I'm here.
Haley, you have like, in your middle name, it's kind of like two middle names put together. It's kind of neat. Heidi, are you here?
I'm here.
Morgan?
I'm here.
Ella?
Here.
Noah?
Here.
Bryn?
Here.
Gus?
Here.
Already talked to Zach. Christian?
Here.
Nick?
Here.
Olivia? Olivia, I have a different name for you, and no, you don't want to know because I'm getting you confused with somebody else from about 30 years ago. Okay. Yeah, see, that's what happens. You know, this is 30 years ago. It wasn't that long ago, and it seems like it was forever. It was just, half a day ago. Noah. Dominic, I already talked to. Ari, I saw. Jack is here. Bryce is here. Jacob, Ari. Darcy is already asking me about Pi. Cora is here, and Kai is here. Awesome. Everybody's here. So my goal is, I have to talk about Bryce, extra credit, right? You're going to remind me of that. So you have two ways to earn extra credit, okay? Parent-teacher conferences are next Monday, the 12th, and then next Wednesday, the 21st. Okay, you guys know I'm part-time. Okay, so teachers are required to have 24 hours of parent-teacher time. 7/11, I know that seems strange, but that's the fractional part of my time, is 15 hours. So I am this trimester doing 6 hours of parent-teacher conference time, not 8. Everybody have that? So Monday, the 12th, and we're doing it by Zoom. Do you guys know that? Okay, you guys know already a whole bunch of more stuff than I do. Okay, supposedly yesterday, your parents or guardians got a message saying, hey, you can sign up for parent-teacher conferences and a time slot, and you get a 10-minute time slot. Somebody's already done that for Monday from 7 to 10, because I'm going to be available on Monday from 6 to 8. Does that make sense? And then from 4 to 8 on the 21st. There's my 6 hours. Okay, I haven't told my wife that it's from 6 to 8. She probably would have said, why didn't you go from 4 to 6? Well, I want to have supper, and I want her to make my supper. Because if I have to make it, it'll be like a peanut butter sandwich or something. So if you or your parent or guardian or you all together schedule and have a conference with me, you'll get an extra credit point. Bingo. Okay, which is 1 point, one assignment, one more point on a quiz. Okay, everybody have that? Now, maybe your parents aren't available, but you say, hey, I want to talk to Kruger for 10 minutes. I'll give you an extra credit. I've had people do that, okay? Or let's say it's not even possible during that Monday and that Wednesday, because I don't know, you guys have decided to go on vacation to some place that has no COVID. I don't know where that would be. North Pole, but it's shrinking, right? It's melting. So I don't know. But let's say they're not available. If they give me a call or send me an email, that will count. Everybody got that? Okay. So that's one extra credit point. It'll go in that column. The next one, Bryce, is even better. Hopefully, if you asked any math teacher in this building how they got through college, they'll say, hey, I was in a group of other math students. I know that seems weird, but we were. Mine, in fact, here's my calc book. I'll go get it. I'll show it to people. I still have it. I was in calculus. I gotta use 44 years ago, I was in calculus. This is my calc book I had. You guys see it? And this was 4 quarters of calc. I only had to buy one book. They don't do that anymore because they want to make money off of you guys. They get a different book for every class, and it'll cost you hundreds of dollars for that book. I think they're renting them out now. Okay. This cost me $16. And if you look on the inside, there are 2 people's names there. One is Jackie. She lived in Linden Hall, A Wing, room 219. And Mike lived in Birch, B Wing, and his room number was 222. Those people were really smart, and they helped me get through calculus. So I know there are people out there, and I know you guys are all remote, but you're still communicating, hopefully. Hey, what'd you get this for an answer? What do you think he meant by this? By God, I know a whole bunch of you were talking Sunday night. Wasn't it Sunday night or Monday night or something like that? Because I could feel the vibrations coming through the air. So if you're able to take a picture of you and other people, and I've seen it happen. Somehow somebody takes a selfie. Like right now, if I took a picture here, I would be on it. All these people would be on it, and you would all be on it, and you'd all get an extra credit point. Except it's in class and doesn't count. This has to be outside of class. Everybody got that? And you get one of those per trimester. So now, Jack, that's 2 points. And we haven't even done a pop quiz yet, but I think a pop quiz will be coming up. Ooh, maybe next week on a Tuesday. I got a feeling, if I can remember. Somebody says, hey, Kruger, I got a cool pop quiz. I did it. I came up with it this summer when I was riding my bike. I go, oh, that'd be pretty cool. And I wrote it and everything. And it's just one problem. It's got like an A, B, C, D, E, F, G, H, I, J part to it. It's kind of cool. So yeah, all my pop quizzes, I don't know how many points they're worth till I write them. Okay, everybody got that? So, any questions from the abyss on that? None? Oh, wow. Okay. So what the goal is today is I have a few notes that I want to make sure everybody understands for tomorrow's quiz. Okay. At the end, remind me to talk about the quiz a little bit so you have an idea. Okay. And then the rest of the time would be work time. So I've kind of talked on, I'm hoping to be done in, I said a half hour. I might be done in 25 minutes or less. Is that okay with everybody? If you have a question. So I am going to share my screen. Christian, can you see my screen?
Yep.
Okay, good. Super duper. All righty. So what I did is, if you have a Casio, there's some things I like about a Casio. And you don't have to have this fancy dancy Casio, but it's great. I think it's easier. That's my feeling. So if you have a Casio, and I'm going to see if I can figure it out on a TI. And if I figure it out on a TI, I'll let the TI people know. Okay. Well, on a Casio, if you go to Shift Setup, right here, you can say derivative and turn it on. And Cora, another name for derivative is what? Oh, that's fine. That's fine. It's on tomorrow's quiz. Okay. Darcy. Slope of a tangent line, correct? And Jacob, another name for slope of a tangent line and derivative is what? Instantaneous rate. Okay. Right? Those are all the same. And so now I've got the slope of the tangent lines on, don't I? Okay, so I'm going to go to my menu, and I typed in a bunch of graphs, and I'm going to draw this one. Okay, and I am going to go shift zoom in right there. Okay, so this is a graph. It is continuous, correct? It is continuous. And the next thing I'm going to do is I'm going to trace. Now notice, can you guys see this all right in the abyss? Okay, I got a thumbs up by somebody who's got a cute cat. I don't know who that is. I have to look. Maybe I can look here. Oh, it's Heidi. Okay. So what I can do is trace. Now, at 0, notice it says error. I think that's stupid. If it was me and I programmed this calculator, it would say DNE. In other words, the slope of the tangent line does not exist. Why is that? Because the tangent line at that spot is vertical. And a vertical line has no slope, correct? We say it's undefined. So what I'm going to do is I'm going to trace, oops. And so I'm at a negative 0.476. And if you look at this, I'll bring this up a little bit bigger. Maybe you guys could see it. Can you guys see the slope of the tangent line? Right? The slope of the tangent line is around 0.5466. And I'm going to move it closer to 0. And if you notice, it's getting bigger, isn't it? And it's positive, isn't it? Okay, I don't want to get there. Now, notice I'm at around a negative 0.04. I'm going to type in a negative 0.00001. Look at what the slope is going to be. It's going to be 718. A slope of 718, Ari, is really slanted, isn't it? It would look vertical to me because I can't tell the difference. So the derivative is going to positive infinity. Does that make sense? So if I go to the other side, I'll come in from the left. And you could see the derivative is getting bigger. Oops, I'm at error, so I got to put in point. Did I put in negative last time or positive? Positive? Okay, I'm going to put in negative this time. I should have been on the other side. 0.00001. There I'm very close on the left-hand side. Oop, exit. Because I got this stupid thing in it. Enter. Here I have a slope of 718. When I went to the other side, now I'm on the right side, it's a positive 217. So as I'm coming into 0, the derivative is going up forever. Everybody got that? And I can see that there's no derivative. So at 0. So this function, this graph, even though it's continuous, is not differentiable at 0. There's no derivative at 0. If I go back and now I graph its derivative, which is what I did right here, and draw it, you could see the derivative as it's approaching 0 from the left-hand side. The slope of the tangent lines are getting really, really big because 718 is way up here, isn't it? And as I approach 0 from the right, the derivative is going up forever, isn't it? So there's an asymptote here. So this is an example of a continuous curve that's not differentiable. And there's no sharp point, is there? I mean, I can touch this thing without causing any blood, right? All right. Olivia, I'm going to turn this one off. You see how that was x to the 1/3? Now I'm going to do x to the 2/3, which I think is kind of cool. I'm going to turn that one on. I'm going to turn that one off. I'm going to draw. Does that have a sharp point? And Ari, you know how I said when I zoomed in, if it gets flat, like a line, you know, like y equals x squared, start to look flat. When I zoom in here, keep zooming in, you're going to see that sharp point. It's never going to get flat. Watch. I'm going to hit shift, zoom in. You can see I'm getting closer. Here's -1 and 1. I'm going to shift, zoom in again. Oh, maybe I just hit enter. Maybe not. This is a half right here. See, that sharp point's always there, isn't it? It's not differentiable there. If I would graph this, let me shift my window back to standard. And I'm going to come up and draw its derivative, which is right here. What's happening here is, let me change my window here. It's too big. There, that'll be better. As you come in this way, if I trace, see it says error again. If I trace here and go to the left, I've got negative numbers in here. So if I type in a -0.001, I get 14.36. If I type in a -0.00000000001, I get a -1,436. Now I'm going to come in from the right, 0.000000001. And I'm at 1,436 positive. So these aren't headed towards each other either, are they? So there are two types of graphs that are continuous and not differentiable. Those with sharp points and those that have a change of concavity, so you have vertical tangent lines. Does everybody have that? Okay. Now, so what am I saying here? I am saying that the limit, as I approached C from the left, right? In my example, 0 was C, correct? The limit as I approach C from the left of f of x minus f of C over x minus C has to be equal to the limit as I approach C from the right of f of x minus f of C over x minus C for it to be differentiable. And differentiable means you can take the derivative at every point in the domain. If you know a function is differentiable, it's guaranteed to be continuous. If you know a function is differentiable, it's guaranteed to be continuous. However, not all continuous functions are differentiable. What type are there? The ones with points? My favorite pointy one is this. Jack, what is that one called? Absolute value. It looks like a V, doesn't it, Jack? Yep. Did I tell you I changed my middle name to Charles Absolute Value Kruger? It used to be Van. I think Van is kind of dorky. Absolute value. I told that to my kids. They thought I was nuts. So this f of x equals absolute value of x. The limit as x approaches 0 from the left of f of x minus f of 0 over x. Why don't I write x minus 0? That's just x, right? So, Noah McDonald, as I come in from the left, what's the derivative on this side? It's a -1. Perfect. What's the derivative as I approach 0 from the right? And those aren't equal, are they? And so like, you can't take the derivative at 0. Now, absolute value of x is a piecewise graph. When x is less than 0, it's a -x. When x is greater than or equal to 0, excuse me, when x is great, let me rewrite this. God, I'm so sorry. Absolute value is a piecewise graph. F of x equals a -x when x is less than 0. It is a positive x when x is greater than or equal to 0. Think about that. Give me a number, Bryn, that's less than 0.
-3.
Perfect. -3. It's like you knew what I was thinking. So what's the opposite of a -3, Bryn?
3.
3. And that'd be right here, wouldn't it?
Yeah.
Bryn, give me a number that's greater than 0.
3.
3. Perfect. And the absolute, and that means I'd be here, right? 3, 3, correct?
Yep.
Now, you'll be asked to take the derivative, and it will also be a piecewise. What's the derivative, Bryn, of a -x?
Negative x to,
Remember, there's a 1 right here, right? And this is a
yeah.
-1, so you're going to multiply those two together and get -1, right?
Yep.
Then you subtract 1 from that exponent.
So it's just -1.
Perfect, which is exactly what Noah said. And that's for x less than 0. And what is it, Bryn, for x greater than or equal to 0?
1.
1. That makes sense to everybody? All right, we're done there. Okay? I have a few extra things I want to talk about. First of all, I've got room in here, don't I? Okay. So this is true. If I have the limit as x approaches c of f of x minus f of c over x minus c, that gives me the derivative, right? The slope of the tangent line at C. Now notice what I said. The slope of the tangent line at C, because that's the derivative means the same thing, doesn't it? Okay. Now, here's the second thing. If I take the limit as delta x approaches 0, or h, of f of x plus delta x minus f of x over delta x, that's going to give me the derivative of the function at any x. It'll give me the derivative formula, correct? Now, we can use that to our advantage to figure out limits. Let me show you. I got to find a good color. Okay, so for this one, the limit as x approaches, what did I pick? 1. Of x to the 16th plus 3x squared minus 4 over x minus 1. And I ask you to figure out that derivative. Now, you guys, some of you may say, I have no idea how to start. Some of you may try to substitute and you'd get 0 over 0, correct? Some of you may say, hey, I can't factor, but I can do synthetic division, correct? You remember kind of doing that? I did long division. You guys might have did synthetic division. Do you remember that at all? Okay. Now take a look at that. This is 16. That means you'd have to have a 15, 14, 13. That would be a pain, wouldn't it? But let's tie in these two together. First thing I ask myself is, and I'm going to choose a different color, do I know what C is? Jacob, do you know what C is? 1. It's right here, isn't it? And then again, it's right here. So, Jacob, do you know what f of x is? Remember, now look over here. It's f of x minus f of c. So what do you think f of x is? This is the hardest one to do. That's what c is. F of x has to be something in terms of x where I'm doing some arithmetic, some computation. Not sure? Okay, can I ask someone else? Can I ask Heidi Danielson? Heidi, do you know what f of x is?
Would it be x to the 16 plus 3 x to the second
Okay,
minus 3?
well, let's just stop here. We know we have to have minus f of c.
Mm-hmm.
And Jacob said this is 1. What's f of 1 if I plug it into here? You get 1 to the 16th.
Oh, 4.
It's 4. So this right here is f of 1. Everybody have that? Are you okay with that, Heidi?
Mm-hmm.
That makes sense. This right here is f of x. Now, Heidi, if I gave you this on a quiz tomorrow, could you tell me its derivative or is it hard?
Would it be 16 x to the 15
Yeah.
plus 3x
Not 3. You're almost.
plus plus
You gotta,
2x?
You got to multiply the 2 and the 3.
Oh. 6x.
6x. Okay. Everybody with me on that? Does everybody see where she got that? So notice it says this is equal to the derivative with c put into it. So I'm going to put what into it? Well, Jacob said c is 1. I'm going to put 1 in it. What does that give me? Well, 1 to the 15th power times 16 plus 6 times 1. Do you know what that is, Heidi?
Would it be 22?
22. That's your answer. Isn't that easier than doing long division or even synthetic division? Cora, do you have a question on that, or are you okay with that? Okay, so what I do is I know this to be true. I get something that looks like this. And the first thing I identify, are these two numbers the same? Then I say, okay, what's the function? If I put that number in the function, do I get this at the end? Everybody got that? So now let's look at an example for this. What if I gave you something that looks like this? The limit as delta x goes to 0. Down here I have delta x. It might be h, right? And I have this. The 4th root of x plus delta x minus the 4th root of x. And some of you may want to multiply by its conjugate, but it won't work this time because that only works on square roots. And these are 4th roots. But Olivia, there's a little hint here. It's delta x. So what is f of x? So look at what it represents. It's this minus this. I gotta see if this person's here. It might be a different. Gus, do you think you know what f of x is in this problem?
Is it the 4th root of x plus?
Take a look. Here's f of with x plus delta x in minus f of x. And I just want to know what f of x is. So what do you think it is?
Or-
The 4th root of what? Just plain old?
X plus delta x?
No, just x.
Just x.
Yep, just this thing right here. Which is the same as this, right, Gus? X to the 1/4.
Yep.
Can you take the derivative of that?
1/4 x, and then raise to the negative 1/4. Or no,
Close.
negative 3/4.
Negative 3/4. And if you got to here, you'd get full credit tomorrow.
Sweet.
Is that making sense?
Yep.
So you have to realize that this right here is this definition. What gives it away? Either there's going to be an H here, there may be whatever this is right here has to match that. Has everybody got that? Sometimes it's a delta T, sometimes it might be T, sometimes it might be H, okay? And it's going to match up with what's here. And so you know that's your function. And all you got to do is take the derivative of it because that's the definition of a derivative. And so we use our rules to help us take that limit. That's what's cool about the definition. Are we okay there? All right, last thing I want to talk about. Bryce, what planet do you live on? Good. Okay, I'm just checking. So have you ever heard of gravity? I'm into gravity. Okay. And we have this, and I don't know what they teach you in science, but there was a guy named Newton that said, I got a function. This is a position function. And he generalized this. So there's a lot of letters in there. Right, Bryce? You got 2.5. Those are numbers. Okay. So G is acceleration due to gravity on Earth. If you go to Jupiter, it'd be different. If you went to the moon, it would be different. Right, Bryce? But we're on Earth. Okay. And on Earth, we have two choices. We have the cool metric system, which says it's a negative 9.8 meters per second per second. Have you ever seen that, Bryce?
I believe at one point.
Yeah. And math people usually write this because we're lazy. Meters per second squared. Okay? Yep. Thank you. Okay? And if you take physics, Mr. Sievertson, we'll do it that way. If it was just me and Cora was the AP calculus math god, I would do it that way. But AP calculus does most of their problems like this: a negative 32 feet per second squared. And that's what I'm going to use here. Okay. Cole, okay?
Yes.
Cole, are you taking physics?
No, I'm not.
No, you're not. Okay. So if I plug this into here, 1/2 times G, or 1/2 times a negative 32, is going to be a negative 16 t squared. T is time, it's seconds. V sub 0 is initial velocity. Noah Jensen,
Yes.
do you just play hockey? Or do you play
And baseball.
baseball?
Yes.
What position?
Pitcher and first base.
Pitcher. Perfect. Okay. So when you throw a ball, you're putting on an initial velocity when it leaves your hand. That's the speed at which it leaves his hand is the initial velocity. Is that making sense?
Yes.
Okay. Have you ever had the ball in your hand and you just dropped it?
Once or twice.
Yeah. Did it go straight down pretty much?
Yeah.
Yeah. You know what the initial velocity is then?
0.
0. You ever throw it up in the air, like straight up in the air, or just toss it up in the air?
Yep.
The initial velocity is positive. Okay.
All right.
Ever get angry and throw the ball down onto the ground because you're mad because you should have struck the guy out and instead you walked him?
No, I always strike them out, but I know some people who do that.
Yeah, I'm going to tell you, I did. Okay. And that's when I realized, you know what, when you walk this is like when you're little, you're like 8, 9, 10, 14, 17, and you walk like 10 people in a row. That's not good.
My friend Owen does that.
Oh, does he? Okay. Owen who? I know an Owen.
Aren't.
Oh, that's not the one I know. So anyway, when I did that, I threw the ball right onto the ground. What kind of velocity does that have?
Like 100.
No. Positive or negative?
Negative.
Negative, because it's going down, correct? And actually, my dad wasn't happy. He said that was a pretty negative thing to do. I go, yeah, negative velocity. Okay. All right, so this is initial height. Dominic, you probably don't do this anymore. Do you ever lay on the ground and look at the clouds when you were little? Oh, I love doing that. Okay. Ever toss a ball in the air when you're laying on the ground? Okay. Ever fall asleep with the ball in your hand as you're laying on the ground looking at the clouds? I have. Okay. You know what the height of the ball is when it's laying on the ground? 0. Correct. Yeah. Okay. Super. If I had the ball on top of my head, you know what the initial height would be? 5 feet, 5 inches. Alrighty. So everybody got that? All right. I got 2 questions. First, I'm going to tell you a ball story. And the ball story is at t equals 0. That's why you see a 0 here, because that means initial time. When time is just beginning at 0. Everybody got that? So that's why you see that's the initial. So at t equals 0, a ball is tossed up. From 32 feet. At a velocity of 16 feet per second. So we're going to stop there and we're going to look at our position function. Kaya, this negative 16t squared never changes. We have a number that's going to go into v sub 0. What is it? Positive or negative? Why? Perfect. Okay. Do we have an initial? Do we have an initial height, Kaya? 32 feet. If it was on the ground, it'd be 0. Correct? You know who told us that? Dominic. And he's right. Okay. So, Ella Gunderson, take
Yeah.
the derivative of this for me.
Negative 32t plus 16.
Anything else?
No, that's 0.
What's 0?
The 32 is.
You killed 0, didn't you? Right?
Yeah.
Okay. So the units of measurement here are feet, correct?
Yeah.
So what do you think the units are here when you take the derivative? Again, it's the slope of the tangent lines of this position function. Do you have any idea what they would be?
That'd be
I think you said it, but you got cut off. Is it still feet?
yeah.
Well, okay, so let's take a look at this. This thing's a parabola, I'm guessing, right? It looks like this. Here's 32. This is some time t. I don't know what it is. Okay. And so this is feet. This is seconds. I have a tangent line right here, correct? And its slope is s of t at a certain time minus s of t at a different time, and down here is t1 minus t2, right? That's the slope, correct? That's the old slope formula or difference. These units up here are feet. These units down here are seconds. So the slope of the tangent line, Ella, has to have what unit?
Feet in seconds.
Feet per second, correct. If this is a position function, Jack, what kind of function would we get that gives us feet per second? Any idea what we would call it? We call it the velocity function. So the derivative of the position function is the velocity function. So it's the same as s of t. Ella, you did such a good job taking the derivative. I'm going to have you take the derivative again. What do I get when I take the derivative of this?
It'd be negative 32.
Negative 32. Huh, I've seen a negative 32 right here. You see this? It's a
Yeah.
constant. You know what this is called? If this is position, this is velocity, you know what the next thing is? That's okay. Not sure?
Oh,
Not sure?
no, I don't know.
Haley, what do you think?
I'm not sure either.
Okay. Noah? Feet per second squared are my units. You know what this negative 32 feet per, it's acceleration, okay? It's the acceleration function. And obviously there's no t when we're doing this problem, okay? Which is the derivative of the velocity function, which is the second derivative. So I put two little tick marks for the second derivative. So we have basically two formulas. Would you agree? One's position, one's velocity. Ari, right? This is position, how far we are from the ground. And this is the velocity, telling us which direction it's going and how fast it's going, correct? All right, so here's my first question. My first question is, when does the ball hit the ground? And so you have two choices. You're either going to use the position function or the velocity function. Noah, is this question asking you about position or is it asking you about velocity? So I got to use this. A negative 16t squared plus 16t plus 32, correct? And I want to know, the question is when, so I'm trying to find time. Would you agree with that? Yeah. So how am I going to do that? What, do I know anything? Did Dominic tell us anything about the position when the ball hits the ground? What is its position when it hits the ground? Zero. So this is when it equals 0. How would you, Noah, attempt to solve that? If I ask it on a non-calculator portion. Yeah, how would you do that? Yeah, how would you find t? I agree with you with everything you're saying. How do you find t? Because this is what I find that students do, and I got to make sure that we don't do that. So how do we do that? You know what Mr. Eckstein told me? He said, is there a number I can divide everything by to make my number smaller? That makes it a lot easier. Can I make it negative 16? Because I don't like that negative there. It just scares me. Is everybody okay with that? So I divide this by a negative 16. I divide this by a negative 16. I divide this by a negative 16. I make my number smaller. And I get t squared, right, Noah? Minus t. Is that right? Minus 2 equals 0. That looks a lot nicer, doesn't it? Now, how do you solve it? Right. And anytime you want to do this, you want to factor. You don't want to move stuff around, okay? You know how you almost move 32 to the other side? That's going to lead to death, okay? You want to factor. So I got t here, I got t here. Two numbers, when you multiply, give you a negative 2. When you add them, give you a negative 1. Positive 1. That means t equals 2 and t equals a negative 1. Now in math, sometimes you get stupid answers. Is there a stupid answer in here? Yeah, negative 1 second. We're not going back in time. So it hits the ground at 2 seconds. Bingo, done. Now, I got a follow-up question. Morgan. What is the velocity when it hits the ground? Again, we have two formulas, one for position and one for velocity. Which one do you think we should use?
The velocity equation.
Yeah. Okay. And what are we going to put into it?
Negative 32t plus 16.
Okay, v of t is equal to a negative 32t plus 16. What number am I going to plug in there?
2.
2, because that's when it hits the ground, right? The input has to be time, correct? So I get negative 32 times 2 plus 16. Do you know what a negative 32 times 2 is?
Negative 64.
Perfect. Do you know what negative 64 plus 16 is?
80. Oh wait, no, never mind. A negative 48.
Perfect. Do you know what my unit is? It's velocity, right? So it's what?
Feet per second.
Feet per second. Why is it negative?
Because it's coming down.
Yeah, it's hitting the ground, it's coming down, correct? Now, here's my trick question. What is the speed, Morgan, when it hits the ground?
48 feet per second.
Exactly. It's just the positive. Everybody got that? All right, that was my last thing to do. Sorry it took a lot longer than I wanted it to, but okay. We'll be coming back to more of these kind of problems. Everybody okay with that? All right. Rest of the time is work time. Abyssers, you got to hang around till 1:45. But if you got questions to ask me, it's a good time to ask. Yes. Yes. Oh, you want me to talk about the quiz? I gotta get out of here. I got some junk in here. All righty, let me talk to you about the quiz because I've already made it. It's green. So, number 1, I asked you to find the slope of a tangent line without, and I say this, do not use the limit definition. You know what that means? You don't use the limit definition. You have to use some of the rules, correct? Like the power rules, okay? That Ella did such a good job taking of. Number 2, I ask you to find the derivative using the limit definition. And I tell you, it's the only problem in which you will have to do that with. Does everybody understand that? Because you don't have a lot of time, right? So just do it there and don't ever do it again. Number 3, I asked you to find the equation of a tangent line. And Olivia, what 2 things do you need to find the equation of a line? This is the 4th time I've said it. Perfect. I give you a picture of a graph for number 4. I'm not going to talk anymore about that. Number 5, I asked you to find the derivative of a function. Number 6, I asked you to find the slope of a function. Number 7, I asked you to find the derivative of a function. Number 8, what do you know about a horizontal tangent line? Anybody know anything about a horizontal line? It's a very special line. It has a certain slope. I think I heard somebody say it. 0 has a slope of 0, correct? So I have a way to figure out what points have a slope of 0, right? How would I figure out what points have a slope of 0? What would you do? Like this right here. Are there any points that have a slope of 0? Well, it's a parabola, right? How would you figure out what gives you the slope of a tangent line? What gives you the slope of a tangent line? Zach Koslowski, what gives you the slope of a tangent line?
The derivative,
Yeah, what's the derivative here?
let's see, negative 2x plus 6.
Plus 6. And I know the slope is 0, correct?
Yeah.
So I can make that equal to 0, correct?
Mm-hmm.
What does x have to be? Because you want a point, right? So you need an x value. What's my x value?
3.
3. How do I figure out my y value?
Plug it in.
Plug it in what? Should I plug it in here and get 0? Because that's what a lot of students do.
No, it's the original.
Yeah, because this gives me y, doesn't it?
Yes.
So if I plug in 3 here, 3 squared is 9, make it negative, it's a negative 9, plus 6 times 3 is 18. What's negative 9 plus 18?
9.
9. It's got a horizontal tangent line at 3, 9. Bingo, I'm done. I ask you to find the average rate of change of a function. I ask you to find the instantaneous rate of change of a function. Ooh, I ask you to sketch 2 graphs. I ask you to do a proof. And then number 12 has A, B, C, D, E questions. It's got 5, but they're not bad. I ask you what's C, what something else is. Everything's in your notes. You guys are working, right? Yes, sir.
Would you be able to like run over like the cosine and this equals negative sine x?
The proof?
Yeah. I know you did that yesterday, but I didn't.
Okay. That's what you want, right?
Yeah. Or like by
You want H or delta X? I don't care.
go delta x.
That's what you have to start with, okay? So the way I set up my limits is I write my limit, and then what I do is a whole bunch of algebra, or trig in this case, and then come up with my limit at the end, okay? But you got to have a limit at the end, okay? So I say this can be expanded. I always forget what it is. If I expand this is the cosine x, cosine delta x.
That's what I'm not understanding. It's like, how is it like cosine x, cosine delta x?
Mr. Karsh was supposed to have shown you that last year. That's one of the identities. When he taught you trig. And somebody said, yeah, he did do that. Well, no, but he may have A, B, right? It's just two things being added in here. It might be X, Y. It's just that you're adding two things and they're different.
Yeah, I read that.
Okay. That's why sometimes when you put H in there, that kind of jogs memory a little bit because the delta X is just so unfamiliar. But that's just, you're adding two things. Does that help? Okay, now you're okay for the rest of the thing? Yeah, that's how you have to look at it is you're taking cosine and you're adding two different values. Okay. And that's how they figured out how, I mean, back in the day before the calculators, how did they know what the sine of 15 degrees is? Well, they knew what the sine of 45 and the sine of 30. So what they would do is take the sine of 45 minus 30 and use this trig thing to know what the sine of 15 is. See, when I was there, because we didn't have calculators, that's what we had to do. Because we knew the sine of 45 was the square root of 2 over 2. And we knew that the sine was 1/2. So we could come up with the exact length of that ratio of 15 degrees. The same thing you can do 75 then too. So you can do increments of 15 by adding and subtracting the ones you know. Yeah, if that's all you needed, if that makes, and I probably should have did a better job teaching that now that I think about it.
Yeah, I just forgot like once you said like a plus b.
Yeah.
So I have a question on like the 75 through 80.
Yeah, all you got to do, there's no work to show. You just look
Okay. So
and just write what the intervals are that where it's continuous.
Negative infinity.
Right, and you can use your bracket notation if you like that or the other. You just know where there's a sharp point, you can't include that value. Where there's a asymptote, you can't, but it's all by picture.
Okay.
There's nothing for you to do.
All right.
That should take you about 5 seconds.
Yeah, I just did it.
And what you're going to see, the reason I give that question, Jack, is because they will give you a graph that looks like this. They give you a graph that looks like this. And they'll ask you, you have to explain why. They'll ask you, is this point differentiable? Or at what points aren't it differentiable and why? Okay, well, it's not here and it's not here.
Right, so it not be on the.
Yes and no, not this, not like this.
And no, not like.
I asked you something that spent a lot of time in on the notes that deal with sharp points. You need to know the two situations, give me examples of continuous graphs that are not differentiable, that are different.
Okay, and then just, yeah, sharp points, and then ask wherever there's ask.
No, not an ask, it has to be continuous. Yeah, wherever you get like wherever that vertical tangent line is, and there has to be a change of concavity. It has to be, I always have a hard time drawing it. It has to be something that looks like this.
So, yeah, we just say.
Do you see that?
Yeah, so like the answer to that would be like wherever there's a change of cap.
Well, I ask you to draw them,
Oh, okay.
okay? And I don't want to be too. I didn't do this. I said, okay, come up with the two different graphs that are that are continuous and not differentiable.
Okay.
But they got to be different. I used to use the word distinct, but then I found out students didn't know. I thought you guys knew words like arbitrary. You guys don't know what arbitrary is, do you? Nobody talks like that except for me. Distinct, you guys don't know distinct means different. Arbitrary means, when I pick a number and I pick 3, that is not arbitrary. That's on purpose. Arbitrary means you pick any number you want.
What would be like an equation for that graph?
That graph, actually, x to the 1/3 power is that way.
Okay.
Which I find interesting because x to the 2/3 now has a sharp point. And I never graphed x to the 4/3 or x to the 5/3. But I would think x to the 4/3 because the numerator is even. I'm thinking when it's even, it's all sharp points. And when it's odd, it has the vertical tangent line. But I haven't verified that. It's just something I'm thinking right now. Dominic, you know that thing that's in your right hand?
Yeah.
Can you bring it up here? Show this to your dad. Get the camera on. I don't know how to run these phones. See everybody tomorrow. You gotta wait till the bell rings. Okay. Is this how you flip it around? Oh, you just did. So you can show that to your dad. He'll get a laugh.